VLSos here. This is a video lesson on the graph of cosine. We're going to see that cosine is a transformation of sine, so we're going to start by reviewing where we got the graph of sine. I have a circle here. I can draw a radius, and if I label the radius 1, then this is the unit circle. I could imagine a point traveling the path on the edge of this circle. And when it does, the path of the point creates a right triangle if we draw a line perpendicular to the horizontal axis from the point. And in this right triangle, the legs of the triangle are the same as the x and y coordinates of the point. The angle of rotation from the positive horizontal axis we can call theta. And we can see that our trig ratios sine and cosine are related in this triangle. The sine of theta is equal to y over 1. We can ignore division by 1, so we can write the simple equation that y is equal to the sine of theta. And the graph of sine came from comparing the y value, or the height of the point, to the change in theta. This angle starts at 0 when the point starts on the horizontal axis, and theta increases to 90 degrees, 180, 270, and then completes the circle at 360 degrees. If we graph the angle in the horizontal axis, putting tick marks at those important places, 90, 180, 270, and 360, we know that the point starts at 0, reaches a maximum at 90 degrees, intersects the horizontal axis at 180, a minimum at 270, and then completes the circle at 360. And the curve that connects those important points is a sinusoidal curve, the graph of sine. Where does cosine come from? Well, we can see that in this triangle, the cosine ratio adjacent over hypotenuse allows us to write the equation the cosine of theta is equal to the adjacent x over the hypotenuse 1. And we can ignore division by 1 again to get the simple equation x is equal to the cosine of theta. But this doesn't help us graph it so much. Let's make a note that if we drew a line connecting the vertical axis to the point, then it would be the same measure as x down here. In this new triangle, which is also a right triangle, we can relate the angle here to x, but with sine. The sine of this angle in this new triangle on the top is equal to the opposite over the hypotenuse. So we could write an equation, the sine, but what's this angle? This angle here is the complement to theta. In the first quadrant, if this is a 90-degree angle, and we've already gone a rotation of theta, then what remains is the angle inside this top triangle. And it can be calculated as the 90 degrees minus the theta that we've already rotated. If we take the sine of this angle, we will get x over 1, or just x. And if x has already been observed to be cosine of theta, then this is also the cosine of theta. Look here. Cosine of theta can be shown to be a transformation of sine. But what kind of transformation of sine is this? How can we see it in our familiar reflection, translation, or dilation? Well, the sine of 90 minus theta can be written as, if I switch these two terms, negative theta plus 90 degrees. These are equivalent. And if I want to see it as a transformation, I'm going to take the negative out and imagine that the theta is changing by subtracting 90 degrees before I take the negative of it. This is important because when we apply transformations, the addition or subtraction is going to be a horizontal slide. And the horizontal slide, in order to understand which direction is correct, needs to modify the theta. And then the dilation, in this case a negative is going to be a reflection, takes place first. So this negative has to affect the 90 degrees. And we can write it like that. This is equivalent, but from this we get the transformations correct. We have a reflection over y, the y-axis. That's the effect of the negative. And then we can see that the correct slide is to the right because we're subtracting. Right by 90 degrees. We can take the graph of sine, transform it with these descriptions, and it will be equal to the graph of cosine. So what does that look like? Very quickly, the graph of sine looks like this. And if we reflect over y, we can imagine that the sine is going to reflect over to the other side. So this positive hump will be on the other side. That's the reflection. And now if we move it right by 90 degrees, the whole sinusoidal wave goes over by 90, which means that this maximum moves over and intersects the vertical axis there. If we can visualize then the sinusoidal wave, the entirety moved over, it'll look like this, where we have maximums at 360 degrees, this minimum is at 180, and we have intersections at 90 and 270 degrees. This is a transformation of sine, and this transformation is the same thing as cosine. What we see here that starts at a maximum of 1 reaches a minimum at 180 degrees of -1 and then comes back up at 360 degrees to 1 is the graph of cosine, which is also the x-coordinate of the point as it travels along the circle.